2.5 Further applications of right triangles. So just in case you couldn't get enough applications in 2.4, here we are again in 2.5. So bearing. There are two methods for expressing bearing. When a single angle is given, such as 164 degrees, it is understood that the bearing is measured in a clockwise direction from due north. So meaning it moves this way, down, moves down, from north. And remember, it's never eat soggy waffles. Solving a problem involving bearing, method 1. So radar stations A and B are on east-west line, 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. Station B simultaneously detects the same plane on a bearing of 331 degrees. Find the distance from A to C. Now, I gave us this nifty little chart, or this nifty little picture. I gave it to us. But what if it wasn't there? Your homework, your tests, you're going to have to draw it. So let's actually take the time it takes and draw it. Piece by piece, let's draw it. Piece by piece. So we have radar station A and B are on east-west line. So east-west line, that means a horizontal line, just like that. So we have station A, make it a little bigger. We have station B, from east to west line. They are 3.7 kilometers apart. Station A detects a plane at C. We'll just say it's here. C. They detect something at C. Okay. Station A detects it on a bearing of 61 degrees. So when we're talking about bearing, that word tells us that I'm working with north, south, east, west. North. The bearing, so it detects something at a bearing of 61 degrees. So it detects something at C, the letter C, not the word C, like the ocean. It detects it at a 61 degree bearing. This isn't 61 degrees. It comes from the north, south, east, west. That's what this was saying. When a single angle is given, such as 164, it is understood that the bearing is measured in a clockwise direction from due north. That's why it comes from the north, comes from the vertical axis because of north. Then it tells us simultaneously at B, they detect the same plane on a bearing of 331 degrees. So again, that word bearing told me from B, we have north, south, east, west. So it had a bearing of 331 degrees. So it's going, it detects it at C and at 331 degrees. So that's goes counterclockwise 331 degrees. Find the distance from A to C. Let's figure out how to find this right here. How do we find that angle? Well, if this is north, south, east, west, isn't this 90 degrees? So angle A would be 90 degrees minus 61 degrees, and we would get 29 degrees. So that's actually how you would get this of 29 degrees. And then when two things simultaneously meet, it's going to be a 90 degree angle. So that's 90 degrees. All right, so let's find this angle right here. So alternate interior angles, it would share the angle with 61 degrees. So now we have our triangle, 29, 61, and 90. So that's how we would actually find the rest of the information if it weren't given. All right, so now let's go ahead and find our missing side. So the given angle that we have that was 61 degrees, right? So we found angle A because it's complementary. So we know we're going to be using 29 degrees. And then what we need to find is adjacent to that angle. That's what we need to find. That's x, which is the adjacent. And we know we're going to use SOHCAHTOA because we're trying to find a missing value. Now, the only other value that we have is 3.7 kilometers. Now, that's opposite angle C. Since that's opposite angle C, opposite the 90 degree angle, that's the hypotenuse. So 3.7, that's the hypotenuse. So if we're working with adjacent and hypotenuse, we're going to be using cosine. So we're going to be using the cosine function to find our missing value. So we have cosine 29 degrees equals x over 3.7. So we're going to multiply both sides by 3.7. So we'll have 3.7 cosine 29 degrees equals x. We plug that into our calculator. We get 3.236092916 is approximately x. All right, so now it's time to round using significant digits. So using our significant digits, we have 2 significant digits, 2 significant digits, and 3 significant digits. So we always take the least, so it'll be 2 significant digits. So to round this using 2 significant digits, it would be 3.2 kilometers equals x. But remember, this is a word problem. You could also say the distance between plane A and plane C is 3.2 kilometers, but it asked between A and C, so why write more? The distance between A and C is about 3.2 kilometers. A correctly labeled sketch is crucial when solving bearing applications. Some of the necessary information is often not directly stated in the problem and can be determined only from the sketch. So you see how if we didn't draw it, we couldn't find that angle, we wouldn't find this angle, so we couldn't find anything else. So by drawing it, we are able to see, oh, this is a 90-degree angle, so I can find 29 degrees. All right, a ship leaves port and sails on a bearing of north 47 degrees east for 3.5 hours. It turns and sails on a bearing of south 43 degrees east for 4 hours. If the ship's rate is 22 nautical miles per hour, find the distance that the ship is from the port. So, yes, we have the image, but what if it weren't here? What if we didn't have it? How would we determine? Let's do that. I'm going to give it to you for the notes, but we're always going to draw it out for the beginning. Okay, so a ship leaves a port and sails some type of distance. So we're talking about a direction. So we're talking about north, south, east, west. Never eat soggy waffles. A ship leaves port. That's going to be our origin. So that's port. It sails north 47 degrees east. So that means it sails northeast 47 degrees. So this way. So remember, 47 degrees, that comes off the bearing. So this is 47 degrees. And remember, the bearing is the northeast southwest. It turns and sails on a bearing of south 43 degrees east. So it turns. So we're here, right? We're here. And then out of nowhere, we start to turn southeast. So southeast is down into the east. So this way. At 43 degrees. So we turned. That means we have another bearing because we turned. Anytime you have another bearing, you turn or anything like that, you have a new never eat shredded wheat. So that's now our new north. And that's our new south. So we turn at another 43 degrees. So remember, it comes from the bearing. So from the bearing, this right here is 43 degrees. Find the distance from the ship to the port. So we need to find this right here. We're given how fast they're going and how long it takes them to do this. Isn't that miles per hour? Or nautical miles per hour? So we can figure out the real distance if we know how long they're traveling and how fast they're traveling for. The first time we travel for 3.45 hours. And we're doing it for 22 knots. So that's how fast we're going. So 3.5 hours times 22 knots, and we get 77 nautical miles per hour. So here to here was 77 nautical miles per hour. Because we knew how long they were going and how fast they were going. Then we turned, we made that huge turn, and we went for 4 hours at 22 knots. So we went 4 hours at 22 knots. So then we get the distance of 88 nautical miles per hour. So here is 88 nautical miles per hour. We filled out almost everything. Almost everything. There's a few things that we can still fill out. If this is 47 degrees, that means right here is 47 degrees, alternate interior angles. So if this is 47 degrees and this is 43 degrees, we are working with a 90-degree angle. So we have a 90-degree angle. That means the rules of SOHCAHTOA and the Pythagorean identities apply here. So we're trying to find a missing side. We have 2 out of the 3 sides, and we did not round anywhere. We didn't round. We just found it, but we didn't round our side distances. So we can use the Pythagorean theorem. So we have leg squared equals hypotenuse squared. So directly across from the right angle, so the 90-degree angle, that's the 90-degree angle right here. So that's what we're trying to find. We're trying to find the actual hypotenuse. So that's x squared. That means the rest are legs. So we have 77 squared plus 88 squared. 77 squared plus 88 squared, we get 13,673 equals x squared. Square root it, and we get 116.93160039 is approximately x. So how many significant digits do we have? Just 2. Just 2 significant digits, just 2 of them. So we're going to round this to 2 significant digits. How do we round this to 2 significant digits if it's 116.9316 so on? Well, I need a 0. So the next closest number, I can't do 117 because that's 3 significant digits. 118, that's not. 119, that's 3 significant digits. What about 120? 120 is only 2 significant digits. So that's why we round it to 120 kilometers. So, nautical miles. Nautical miles. So the ship is about 120 nautical miles from port. Example 3. Using trigonometry to measure a distance. The subtense bar method is a method that surveyors use to determine a small distance d between 2 points P and Q. The subtense bar with length b is centered at Q and is situated perpendicular to the line of sight between P and Q. Angle theta is measured, then the distance d can be determined. So, you see the people on the road that are have that little camera looking thing on a tripod? This is what they're doing. They're trying to find really, really, really tiny, tiny distances. That's what they're doing. It's crazy, right? Alright, so we're going to find d when theta is 1 degree, 23 minutes, 12 seconds, and b is 2.0000 centimeters. Why do they do that? Because of the significant digits. And then b, how much change would there be in the value of d if theta measured 1 degree larger? So we need to find d. That's this right here. So now we can actually separate this into one little triangle. So now we're just working with one triangle. So if we're standing at theta, now that's this right here, this whole thing is theta. But we're only working with half of it. How do we know half? Because it told us that we're halving the distance. Right there, b over 2 means that those are halved distances. So we know we're not working with theta itself, we're working with half of theta. So half of theta. So we're working with opposite and adjacent, but what we need to find needs to go on top. So if I do that, opposite would be on top. It would be b over 2 over rd. We don't like that. We want what we need to find on top. So instead of using tangent, we'll just use cotangent. So it'd be CAO. Remember, it's just the reciprocal. So we're going to be using cotangent theta over 2 equals adjacent, which is what we need to find, over opposite, which is the b over 2. Okay, let's fill this out. So it tells us that theta is 123.12. So let's plug it in. We have cotangent theta, which is 123.12. So 1 degree, 23 minutes, 12 seconds. And then that equals adjacent over opposite. So adjacent, we have our distance that we don't know, we're trying to find. And then over our opposite, it tells us that B is something. It tells us B is 2.00000, whatever, how many zeros. You only have to put 2 when we're actually working with it, so 2. Now, it's a little hard to work with degree, minute, seconds, so we're going to convert this. We're going to convert minute, degrees, seconds. We're going to convert that to decimals. So let's convert our theta into decimals. It's just easier to work with our calculator. So we do 1 degree plus 23 over 60 degrees plus 12 over 3600. We add that all up and we get theta equals 1.3866666. There's 6 of them. 7. So let's change that. Okay, good, we changed it. And then we have distance over 2. There we go. Sorry. This part right here. I forgot the b over 2. b over 2. Okay. So let's simplify this. We have cotangent 1.386666667 over 2 equals, so this right here just cancels out to 1 equals d. Great, but we can't plug cotangent into the calculator, so we actually need to do the reciprocal of it because we need to plug this into our calculator. So using our calculator, we need to use the tangent function. So with our calculator, remember we have to take the reciprocal 1 over the function itself. So remember how cotangent's on top here, so we need to keep tangent on top. So we'll have tangent 1.386666667 over 2. So we plug that into our calculator and we get approximately, so we get D is approximately 82.622000828, and we're talking about centimeters. And we need significant digits. So how many significant digits do we have? We have 5 significant digits. So D is about 82.622 centimeters. That's it. We found the distance. This is a word problem, but just since it says find D, D is this. That's fine. Alrighty, part B. How much change would there be in the value of D if theta measured 1 second larger? So, if theta was 1 second larger, we're talking about 1 degree, 23 minutes, 13 seconds, because 1 second larger it goes from 12 to 13. That's it. So if we plugged it into our formula that we just came up with, so we could plug it into this, we could plug it into that, except all we would need to change is that number there. So we would just change it to this. So we would first change this to decimal form. So we change this to decimal form, and we get 1.386944444. 6 fours. 5 fours. 5 fours. There's 5 of them. So we plugged it in. All we would have to do is just plug it in. So we would plug it into 1 over tangent 1.386944444 over 2, and we would get about 82.60545,429. So the difference, that's what it's asking. What's the difference? So we subtract them. We have 82.622000828 minus 82.60545,429, and we get the difference is about 0.01655,399 centimeters. That's what it was asking. What's the difference? That's it. We found the difference. How much change? That means, what's the difference? That's a synonym for what's the difference? What's the change from one thing to the next?